Hello, and welcome to your nightly news at 9 on SNRNPS, your source for all things bio. I'm your host, Sally Schwan, here with tonight's news. First up, just a follow-up of last night's news, we've discovered that the cat is indeed out of the bag. Now on to the main story. Right now, as we speak, the race of a lifetime is occurring. The Olympic nervous relay team is in action in order to convey an electrochemical message through the body. We are especially lucky as today we've been given special permission to view one of their races, and astrocyte is at the scene. It's an action potential packed race here this afternoon, Sally, and I'm here with the scoop. The nervous system neurons are going against the endocrine hormones, and the neurons are expected to blow the hormones out of the water. But here's the thing I learned today. The neurons have this down to such an efficient system that they're like a row of dominoes falling. I mean, each one triggers the next part of the race. I'm gonna stay here and see if I can get more insider information for you, but until then, back to you, Sally. Thank you, Anne. I think it was about time that we move over to our resident biologist to shed some more light on this amazing process that Anne is witnessing. Live from the lab downstairs, take it away, Nil.
Nil by the science guy.
It certainly is an exciting process, Anne. One of electrical excitation, to be exact. An electrical signal is created by charged molecules moving into and out of the cell, and the signal moves down a part of the cell called the axon. This process is called an action potential and can be broken down into 6 steps. Please consider the following. 1. The resting nerve cell, or neuron, is how it usually is. Nothing special yet, until bam! 2. Something called a stimulus happens and causes an action potential to occur and an impulse to start. Step 3 is depolarization. Step 4 is repolarization. Step 5 is hyperpolarization, and step 6 is return of the neuron back to its resting state. All of these steps deal with changes in movement of electrically charged molecules into and out of the cell, until after being positive inside and then to negative inside, the inside of the nerve cell finally returns back to normal. Now time for vocab time! Yeah! First up, ions. Ions are charged atoms or molecules. In other words, they are atoms or molecules that are either positive, yay, or negative, boo. The ions involved in the action potential we talked about today are Na+, or sodium, and K+, or potassium. Second, words like depolarization, repolarization, and hyperpolarization basically mean the charge inside of the nerve cell or neuron is changing. That's all for this episode of Nil Bai's Science Time. Back to you, Anne. Thank you, Nil Bai. Now we're back with breaking news. In the last few minutes, Anne Astrocyte was able to obtain an interview with one of the stars of the nervous relay team. We go live to the scene. We are here live with a very special treat for you all. Calling in from inside the neuron is Nora N.A. one of the stars of the team. How are you today, Nora? I'm great. I'm glad we're able to do this.
Me too. Okay, so I know you're super busy, so I'll just ask you a few questions. But I have to know, is it tiring doing what you do all day?
Most of the relay isn't bad. We NA pluses get to go with the flow into the neuron where there are less of us during depolarization, and K pluses have the same experience, just in the opposite direction during repolarization, so that doesn't take energy. The only part that does take some energy is the sodium-potassium pump during hyperpolarization, where we're either pumped back into the cell, in K+'s case, or out of the cell in Na+'s case.
Wow. Okay, just one more question. What makes the neurons the favorites to win this race against the hormones?
Well, the answer's simple. We respond faster. Where the endocrine hormones release chemicals throughout the body to relay their slow, long-lasting message. We simply have to relay a electrical signal and release chemicals to a specific target in order to relay our short-lasting but fast message.
Thank you so much for your time, Nora. I'll let you get back to your work now.
No problem. Thanks for having me. Well, there you have it. The inside scoop from a real live working NA+. That was truly a once in a lifetime experience. Well, I guess this process happens inside of you every day, your whole life, but you get what I mean. Anyway, I will truly never forget it. Until next time, back to you, Sally. Thank you, Anne. You definitely conducted that interview to its fullest potential. Sadly, with that, our time is up for tonight. Until tomorrow, this has been SNRNPS, here with your up-to-date knowledge, bringing you all things biology.